Continuing with topic 1.10 and 1.13, consider the piecewise function for h of x below. Determine all x values where h of x is discontinuous and classify each as removable or non-removable. So again, pretty much this is a piecewise function like always, right? So we want to make sure that we know where it's discontinuous. And since we have a piecewise function, usually, again, where this happens is where we have the jumps, right? So this is where my text is a little bit messed up. I hope yours isn't. So pretty much here, the first jump we see at is at -2, right? And then our interval continues from -2 to +1, and then from 1 to 3, and then for 3. So in a piecewise function, that's pretty much where you want to look for discontinuities, all right? So the first one, remember, we have the three conditions. F of c is defined. The second one is that the limit as x approaches c of f of x exists. And the third condition is pretty much that those two are the same, right? The limit as x approaches c of f of x is equal to f of c itself. So let's see if the first condition, so our first limit is at x equals -2, right? So let's see what happens at x equals -2. So first let's find the function itself. So we're looking at h of -2, and that's equal to. Now, if you remember, again, the equal to part is at the bottom, so that means I have to be using this function, x squared minus 9. So that's going to be -2 squared minus 9, and that's equal to +4 minus 9, which is -5. All right, so that's our first condition. Our second condition, again, is that the limit exists. And then for us to determine that the limit exists, we have to see what happens from the left and from the right and make sure those two are equal. So second condition, the limit as x approaches -2 from the left of h of x, and then we're looking at the top function. So that will be 2 times -2 minus 1. So that's -4 minus 1 gives us also -5. All right. So let's look at the right side limit as x approaches -2 from the right of h of x. And now we're looking at the bottom function, right? At this one right here, x squared minus 9. Plug in -2 again. We're going to get +4 minus 9. Sorry, jumping ahead. And that's also equal to -5. And then the third condition, right? So here we can determine pretty much, therefore, the limit as x approaches -2 of h of x exists. And then our last conclusion is that the limit as x approaches -2 of h of x is also equal to h of -2. So at x equals -2, we know that the function is continuous. All right, so nothing happens there. Now, let's look at our next endpoint, which is at +1, right there. All right, so I'm going to continue down here. So let's look at the left side. First, let's see where the function is defined at. So the first part, right? So at x equals +1, which is, again, the next jump we do right there on the piecewise function. So h of 1 would be equal to, in this case, I have to use the bottom function, 3x plus 2. So that would be 3 times 1 plus 2 is equal to +5. All right. So the second condition, we want to make sure that, again, we find the limit from the left side of 1 as x approaches 1 of h of x. And then, again, that would be the top function, x squared minus 9. So that would be 1 squared minus 9, which is -8. And then look at the limit from the right side of x of +1 of h of x, and that's equal to, again, use the bottom function. That would be 3 times 1 plus 2 equals 5. So now if you notice, again, these two values differ. So we can say, therefore, the limit as x approaches 1 of h of x does not exist, right? And since that condition is already not met, the third one is also false, right? The limit as x approaches c of, in this case, 3, I'm sorry, or 1, not 3, 1, of h of x does not equal, right, h of 1. All right, so again, in this case, since these two limits differ, we can say that this is at x equals 1, h of x is discontinuous. And in this case, we can say that since these two have it's a jump right there. We're going from -8 to +5. We can say it's discontinuous and non-removable. All right. So that's pretty much our second jump. All right. So let's look at our third jump on the graph, which again, in this case now is going to happen on 3 right here. So if you notice already, there is no equal sign on the bottom of this right there, right? Or at the bottom of this. So at x equals 3, at x equals 3, we already know for sure that the function is not continuous because the first statement is not true, right? H of 3 is undefined. All right, so we can say it's discontinuous, is discontinuous, but we have to know what type of discontinuity this is. Is it a hole in the graph or is it just something else? So let's see what happens. So h of 3 is undefined. Now let's look at the limit. If the limit does exist, that means there is just a hole in the function. So let's see, the limit as x approaches 3 from the left side first. So that means we're going to be looking at the top function, right? 3x plus 2 of h of x. So that's 3 times 3 plus 2 equals +11. And then the limit as x approaches 3 from the right side of h of x. Now we're looking at 4x minus 1 is equal to 4 times 3 minus 1, which is also 11. So since we're approaching both the same value from both the left and the right, we can say that the limit as x approaches 3 of h of x exists, right? So here, since it exists, we can say that it is discontinuous, right? But since it is undefined, right, h of 3 is undefined, so this would be a removable. So it's discontinuous and removable. All right. Now, the easiest way to determine these again is pretty much you guys can look at the graph for this. And if you're going to do this in Desmos, just do it separately and then use the squiggly brackets to define your intervals. So here we're going from x is less than a -2. So if we're coming in from the right side, if you notice right there, boom, we reach -2 and it's undefined. And then if we're coming in from the right side, if you notice, we go towards -5, which is what we found initially. And then from there, we approach 1 from the left side, and that leads us to undefined, right? Which is we said it was -8, right? It's approaching -8. You guys can see right there. It's getting closer to -8. And then from the right side, it's going towards +5. So that's where they differed, right? And that was where the function was also defined at. And then the last one we found there was a removable discontinuity. Again, it is undefined at +3, and you guys can clearly see it right here. When we reach 3, the function is undefined, but it still continues, right? And we are approaching the same value from both sides. We're getting closer and closer to 11.